Okay, so we're going to go over the review sheet today. Now, the first question we're looking at is question number 1. Now, it's asking us kind of describe the transformation, match each type of transformation with an example and a description of how it affects the graph. Now, the first one, the description says it moves the graph of f of x 2 units up. So what we're talking about here is a translation, because if we move it up, down, left, or right, the type is a translation. We're talking about a translation. It's moving it. And the only one of these that moves it up 2 is y is equal to f of x plus 2, because when we add something to the outside of the function, it moves it up or down. So it would be this one here. Now the second one says moves the graph of f of x to a symmetric position on the opposite side of the x-axis. This would be our reflection, because it's reflecting it across the x-axis. And reflections across the x-axis, we have it as y equals negative f of x, because if the negative is outside of the parentheses, it's across the x. Enlargement, when we're making something, or enlarging something, we're making it bigger, so we're talking about a stretch. It would be a vertical stretch. And when we stretch something, we are multiplying the outside by a number greater than 1. So the only one that works for that there is f of x equals, or f 2 times f of x. And kind of by elimination, the last one is shrink, because when we reduce something by 1/2, we're making it smaller, so it would be a shrink. And by 1/2, so y equals 1/2 f of x. And that's all we have to do for this here. Any questions on the first one? Okay. Let's look at question number 2. Use the graph f and g to describe the transformation from the graph f to g. So going from f to g. Now when I look at g of x, I have f of x minus 3. So since we have something added or subtracted outside the parentheses, means it's either moving up or it's moving down. So this here would be a translation vertically, because it's moving up and down. And it would be 3 units down. And that's it, because minus 3, negative, is down, since it's outside. Outside's up and down. Since it's negative, it's going down. And it's going 3 units down. Now this one here is similar, because we have f of x plus 1. Since it's on the outside of the parentheses, it is vertical. How far are we moving? 1 unit up. Plus 1 on the outside is up or down, and since it's positive, it's moving up, and it's moving 1 unit. Here, this time, the number is on the inside. So it's inside the parentheses, it's moving to which direction? Left or to the right, which is going to be horizontal. Well, how far is it moving? 5 units to the left, because whenever we're inside parentheses, it's doing the opposite of what we think. So since it's plus, it might seem like we're moving to the right, but we're actually moving to the left. Any questions on any of these here so far? We good with these here? We're still tracking? Okay. Let me erase this. So I'm looking at this here. H of x equals negative f of x. Negative f of x. When we talk about negatives, we're normally talking about what? Reflections, yes? So here, this would be a reflection across the what? X-axis. All right, guys. So this here is across the x-axis. So let's look at the next one. So this one here, this time we have f of negative x. So the negative is inside the parentheses. If the negative is inside the parentheses, it's a reflection across the inside the parentheses is y, outside of the parentheses is x. Inside the parentheses is y, outside of the parentheses is x. As long as it takes the right answer. Okay, guys, let's look at this next one here. So we're looking to see what happens. So our new function is this here, 4 times f of x. So if I have a number being multiplied outside the function, we're talking about a vertical, what, stretch or shrink. This here would be a stretch because, and it is greater than 1. Because if it's greater than 1, it's a stretch, and this one is a stretch by a factor of 4. Because if it's between 0 and 1, if it's a fraction, then it would be not a stretch, but a shrink. Questions on this here? So this one here, again, we have a number being multiplied outside, so it would be a vertical what? Shrink, because it is what? 1/6. So it is smaller than 1, so it would be a vertical shrink of the graph by a factor of 1/6. And if we check it, okay. Let's look at this next one here, number 9. So when I look at this here, I'm going to plug in the values for x and y. And because it didn't move, we're going to really look at these here, -2, -1, 0, 1, 2. If we do -4, well, the absolute value of -4 is 4. 4 minus 4 is 0. It really doesn't give us that vertex, the lowest point. Because if I plug in 0, well, the absolute value of 0, well, that's 0. 0 minus 4 is -4, yes? Well, let's plug in -1. Well, the absolute value of -1 is 1. And 1 minus 4 is -3, yes? Let's do 1. Well, the absolute value of 1 is 1. And 1 minus 4 is? So that is our lowest point, is at -4 on the y-axis, because it just moved it from 0, 0 to 0, -4. So when we do this here, 0, -4 is going to be 1 point. And then I can go 1, -3. Then we do it again, we would click, well, right, it would, there we go. And we graph those 2 points. 0, -4, 1, -3, -1, -3. Now we have a few other things to look at. We have these here. Choose the statement that best compares the graph d of x equals x minus 4 to the absolute value of x. Well, it is a vertical translation of 4 units down because it's outside, -4, we're moving it down 4. Now we have the domain and range. Now the domain is always going to be all real numbers. The domain is always going to be all real numbers. Now, because the graph is going up, both sides are going up, it's going to be y is greater than or equal to the smallest y value, which for here works out to be -4. So the range would be y is greater than or equal to -4. Questions on this here? Any questions on this one here? Let's look at this one here. So x plus 1. Well, that's moving it 1 unit to the left. It's a horizontal translation of 1 unit to the left. So we have this here. Now the domain is going to be all real numbers because the domain is always all real numbers, yes? So let's see what the y is after we graph it. So for this here, we can still do our x and y values. But instead of starting at -2, we start at -3. And if we plug these in one at a time and did the calculations, we would end up getting 2, 1, 0, 1, 2. Because if we plug each one of these into the absolute value and simplify it, we would get 3, 2, 1, 0, 1, 2. And the lowest point for this here is at -1, 0. And then 1 point to the right would be at 0, 1. And 1 point to the left we would have this here. So we'd point our first one to -1, 0 and go up to 0, 1 and then -2, 1. So here, if we look at this here, the smallest y value is at y equals 0. And they're going up. So here, it's going to be y is greater than or equal to 0. Questions on this here?
Sorry.
Yep. So we want to do this one and then this one. And this one. 9. Any other questions on this one here? Now this one here, we have a 1/3 x. Since we have something being multiplied outside, this would be a vertical stretch or shrink. Shrink because it's between 0 and 1. Now we also know the domain is going to be all real numbers because it has to be all real numbers. I'm going to help you all out with this one here because this one here doesn't work well with -2, -1, 1, or 2 because of the 1/3. Now if we plug in -3, 1/3 times the absolute value of -3. Well, the absolute value of -3 is +3. So 1/3 times 3 gives me 1. If we plug in +3 into the absolute value, we end up getting 1 as well. And anything times 0 is going to be 0. So if we were to graph this, well, we'd start out at 0, 0. And at -3, we are at 1. Now, at 3, we're also at 1. So a vertical shrink makes it open bigger. Vertical stretch makes it open smaller. But if we notice here, the smallest value of y is at 0, and it goes up. So for this here, our range is going to be y is greater than or equal to 0. And that's it. That's all we have to do for this one here. Any questions on any of these here so far? But you can always look back. Well, what is 1/3 times x? What is that transformation? So 3 times the absolute value of x, that would be what? A vertical or horizontal, vertical stretch or vertical shrink? It would be a vertical stretch because the number being multiplied outside the absolute value is greater than 1. Now the domain is going to be all real numbers. And we'll look at the range here in a little bit. Now we're going to plug in the values of x and y. So our x values, we can do -2, -1, 0, 1, 2. And again, we're just plugging these into the absolute value. So if we plug them in one at a time, if I plug -2 in, well, the absolute value of -2, well, the absolute value of -2 would be +2. And 3 times 2 is 6. Then if we do -1, well, the absolute value of -1 is 1. And 3 times 1 is 3. We can do the same thing for 0. Well, the absolute value of 0 is 0, and 3 times 0 is 0. So when we do the next one here, we're going to look at 1. So 3 times the absolute value of 1. Well, the absolute value of 1 is 1, and we get 3. And well, really, I have enough with these here, because I can graph the first one, 0, 0. Now at 1, our next one, we have 1, 3. And that will give us our point. The other one we can start at 0, 0, and then we have 1, 3, and we'll get our graph here. So we're going to graph 0, 0, and then 1, 3 to get one side. And then we do 0, 0, and -1, 3 to get the other side of the graph. And again, if we notice, it starts at 0, the smallest y value is 0, and it goes up. So our range is going to be y is greater than or equal to 0. And that is it for this one here. Now, -3/2. Now, because it's negative outside, it's going to be a reflection across the x-axis. That's one of the ones we know for sure. So there's 2 that have a reflection in the x-axis. Now, since the 3/2 is being multiplied on the outside, it would be a vertical stretch because it's greater than 1. So a vertical stretch and a reflection in the x. There's only one choice that actually works with that. And again, the domain is going to be all real numbers. So part of the question is saying that this is a vertical stretch by a factor of 3/2, and it's a reflection in the x-axis. And the domain is all real numbers. Now, if we were going to go through and graph it, we would use our points. And if we found the points, one of them is going to be 0, 0. And if we plugged in 2, because we'd get a fraction at -1, or at 1, and at 2, we would actually get -3. So this would be one side. And the other side, if we found our points, would be at -2, -3. So really the points we used were 0, 0, 2, -3, and -2, -3. And we really got those just from plugging those numbers in. If we plugged all 5 in, we would get these points. Now, if we notice on this one here, the graph is going down. It's opening down, which would mean the range would be y is less than or equal to 0. Any questions on this here? This one here, I'm not going to worry too much about these here because it's okay. The graph shows you the speed. Choose the part of the graph that describes you running at a constant speed. So if it's constant speed, is it increasing, decreasing? No, it's remaining the same. So which part of this graph is remaining the same? C. And C is going to be the correct answer. Okay, whatever. The graph shows you shows your speed during a run. Choose the part of the graph that describes your speed when you increase at a constant speed. Well, this would be A, because A is increasing. B is also increasing, but since it's curved, it's increasing at a faster and faster rate. So this here would be A. Now this one here, so increases your speed at a faster and faster rate. Well, that would be B because it is curved going up. Any questions on these here so far? Are we good with these here? Okay, well, let's look at the next one. Okay. Now this one here is describing the relationship between time and volume of the balloon. So as time increases, so as we're going this way, what happened first? What happened to the graph first? It increased, yes? So the first thing it did is it increased at a constant rate. And then what happened? Well, it kind of went flat, so it stays constant because it went up and then flattened. Then what did it do? It went up again, yes? So after that, it increased at a, well, then it flattened off again, so then it stays constant. And then lastly, it increased at a constant rate. So it increased at a constant rate, it stays constant. It increased at a constant rate, it stayed constant. And then it increased at a constant rate. Questions on this here? And that's all we have to do for this here. Okay. Now this next few here is asking us to kind of show the graph. So from the changing from the distance from the ground as your friend swings on a swing. So as you're swinging on a swing, you're going up, away from the ground, and then back towards it, yes? And then away, and then towards. So the distance from the ground should be what? Increasing, and then increasing, then decreasing. So the one this best fits would be this one here. And, yeah. So it's going to be this one. It's going up and down, up and down. And that's it. That's all we have to do for this. The value of a rare quark increases at a faster and faster rate. So it's going to continue to go up faster and faster, yes? Which one of these four increases at a faster and faster rate? The bottom left, because it's curving up. Yes? And that would be it. You're typing at a constant rate, then you pause to think about your next paragraph, and then you resume typing at the same constant rate. Which sketch is this here? It's going to be the bottom one, because that time when you're not typing, the words per minute would be 0. So that one there's a little tricky, but it would be 0 for that point. Okay. We have these last three here. So when we look at this here, we want to see what value or what inequality does the value of x make true. So when we look at this here, we're looking at -2. So would it be the top equation or the bottom? So is x less than -2, or is it greater than or equal to -2? Or equal to, because it's equal to -2, yes? So would we use the top equation or the bottom? We'd use the bottom. We'd use x plus 3. And I'm going to plug -2 in for x. So -2 plus 3 is 1. So the value for this here, the value that would go in here would be 1. Yep, it's going to keep telling me that. Any questions on this here? Okay, well, let's look at it again with x equal to 0. Well, is 0 less than -2 or greater than -2? 0 would be greater than -2. So we're still going to use the bottom equation. We're still going to use x plus 3. And we're plugging in 0 for x. Well, 0 plus 3 would be 3. So the number that goes in here would be 3. Any questions on this here so far? And I think if you check it, that gives you the right answer, yes. Okay. Let's look at the next one. -4. Is -4 less than or equal to -1? Between -1 and 2, or greater than 2? Where's -4 going to be at? Well, -4 would be less than -1, yes? So that means I'm using the statement -4 plus 4. We'll plug in -4 for x, and we'll get this negative. Well, negative and negative make a positive, so we would have 4 plus 4, which is 8. So the correct answer for this is 8. Please, 1. Any questions on this here so far? Last one here, x is equal to 1. So which statement is this making true? The top one, the middle one, or the bottom one? Is 1 less than or equal to -1? Between -1 and 2, or greater than 2? in the middle one. 1 is between these two values, yes? So here it just says this is equal to, not that. It just be equal to 3 because there's no x, it's just 3. And that's it. That's all we have to do for these here. It really didn't like that I didn't check these. I don't know why it's not working now. Okay, and that's it.